Hey guys, Pankaj here. Welcome back. In today's statistical video, I'm going to talk about another statistical measurement that is nothing but covariance. Okay, so we'll see what is covariance, where exactly it used, and how you can infer the data, how it is correlated from different data. Okay, with the help of covariance. So let me share my desktop. Okay, so here is the agenda for today. We are going to talk about covariance. So let's read what it is. Covariance measures the direction of the relationship between two variables. Okay. A positive covariance means that both variables tend to be high or low at the same time. A negative covariance means that when one variable is high and the other tends to be low. Okay. So let's see with the help of whiteboard what exactly I mean to say here, or what exactly covariance concept is. Okay, so let's say you have I'll just prepare one graph here. With the help of graph, you will understand what is happening. So let's say you have your x-axis and here a y-axis, okay? And here you have, let's say some x data is there and y data is also there, okay? So with the help of this plot, you will be able to understand what is happening. Okay, this is one graph, and let's say I plot another graph. This is your x, this is your y, and this time I plot like this. Okay, so let's say x is very high, but y value is just opposite. Okay, so by looking at the graph, you can easily tell whenever x is going high, your y is going down. Right? In this case, in this particular graph, right? When x is going high, your y is also going high. In this particular case, when x is going high, your y is going low. Correct? You can see basically there will be regression line here, which I'll talk in the machine learning once we talk about linear regression. Right? If you are going to plot a regression line here, so it will be like this. Okay. So this clearly shows when your x is going high, your y is also going high. X and y both are going high. Okay. Whenever you plot a regression line here, your x is going high, but y is going down. So whenever x is going high and y is also going high, this is known as positive covariance. And when x is going high but y is going down, it is called negative covariance. Okay. So I'll show with the help of formula also how exactly this is getting calculated. Okay. Then you will easily understand how that mathematical function works. And this is just by looking at the graph, you'll say this is positive correlation and it is having negative correlation. Okay, by just seeing up and down. Okay, let's say you have another graph where your x data is going, it is going up, but your y value is not at all changing. Okay, it may be looking like this. Okay, let me just change color. So you have value like this. So y is always constant. Okay, so basically this is not at all showing any relationship. Okay, maybe zero correlation you can mention. So with the help of formula, you will get the value which is very near to the zero. There is no correlation. No matter what is the x value, y is always constant. It is always going to be like this. Okay. So now let me talk about the formula. How exactly we can prove it. So here, first of all, we'll see what is the variance. We have already seen, right? Variance is nothing but this is here is the formula for variance 1 by n summation of all values I from 1 to n x of I and subtract this x by their mean. Okay, that is nothing but the mean. This is nothing but mean of the value. Okay, and take this. Okay, this is what we saw variance. Okay, now what is covariance? So how you calculate basically covariance? Let's see the formula. So this tells basically 1 by n, very similar formula. Okay, I equal to 1 to n, and here xi minus mu and multiply by yi minus mu. Okay, so basically, as I mentioned, right, you have two values, right, x and y. So when your x goes, what is the response of y? When your x goes up and down, what is the response of y? So basically, you are plotting y with respect to x, correct? So here you are calculating the covariance of x for y. Okay, so variance of y with respect to x, you can say like that, a covariance between x and y variable. Okay, so we would like to see the relationship between x and y when x goes high, what is my y response? Is it going up or down? Okay, that this formula will tell. When x is going high, what is the response of y? When x is going down, what is the response of y? Okay, those things you can easily calculate using this kind of formula. Okay, so this is the covariance formula. If you very closely see this, right, what is happening here? We are subtracting mean of x with xi and mean of y with y, right? If you see or you compare with this formula, covariance and with variance, so what is happening in the covariance, or sorry, in the variance, we can write like this also, 1 to n xi minus mu xi minus mu. We can write because this is square, right? So this multiply that, this will be square. So basically you are calculating variance or maybe covariance x with respect to x. Okay, so that is what same thing we are doing. Instead of x, we are taking x with respect to y, or y with respect to x. What is the relation between those two variables? Exactly same formula, only thing is here x and y will be there, and here you have only both x versus y. So I'll show this with the help of heat map also, why when you take two variables and both variables are same, your correlation will be very high. It will always 1. Okay, when we talk about other variable, it may be minus, it will be positive, or it will be negative, and it will be some value anywhere between, any number. Okay, so that's the difference between variance and covariance, and that's how calculate. This is the formula. You guys should remember that. Okay, so let's see all those with the help of data set. Let's say I got some data set. I am doing some statistical analysis or exploratory data analysis on that data, right? So we'll just plot quickly and we'll see whether it is positive correlated, negative correlated, just by looking at the graph, and we'll do a calculation of covariance with the help of formula. Okay, and we'll see what is their value. And we'll plot that value with the help of heat map also. You'll see whether it is positive correlated or negative correlated. Okay, guys, so let's go to notebook and import all the libraries. So I'll just import numpy as np. I may need or may not need, so that's okay, but I will definitely need import matplotlib dot pyplot as plt. Import cborn for loading some toy data set. Cborn as sms. Okay, let's load that. Okay, so it is loaded. One more thing I wanted to talk about this particular graph. So let's say you have x and y. Okay, this x is nothing but, let's say, height of a person, and this is nothing but weight of a person. Okay, so let's say height is, let's say, 100, and weight is, let's say, 20 kilogram. Okay, and let's say 120, and this is nothing but your centimeter, and this is in kg. Maybe I'll take 40 kg. Okay, 120 is 60 kg, and 160, and let's say 80 kg, and maybe 90 centimeter. Let's say you have maybe 20 kg. Okay, so whenever you plot correlation, you may see, okay, as x goes high, y is also going high. So basically, when height is increasing, automatically weight is also increasing. Okay, so assume that after you calculated or after you collected the data between height and weight, and let's say you change the unit of height, instead of centimeter, you took, let's say, feet. Okay, so let me use this. So now height is nothing but feet. Okay, and weight is nothing but in pound. Okay, that is represented lbs. Correct. So whenever you calculate correlation between these, right, our covariance, this covariance of height and weight may not be equal to height and weight of centimeter and, let me mention, centimeter and kilogram. Okay, and this is nothing but your feet versus lbs, and that is the major drawback of having covariance. Okay, so basically, if it is having positive correlation, when I change the unit, this should also have positive correlation, right? But that is not the case. It will not be equal to. Okay, so this kind of problem cannot be It cannot be determined with the help of covariance. To fix this problem, we have something called Pearson correlation. Pearson correlation, which we'll see in the next video. Okay, how to fix that problem and how basically Pearson correlation solves this particular problem. When you change the unit, it should still have same covariance. Okay, we'll see in the next video. So let's prove this particular thing, just covariance. I'm just going to load a data set in data frame called SNS dot load data set. I just use tips data set. We have already seen in exploratory data analysis also, but I'm just going to show that it has a couple of numerical values, guys. So we'll see what exactly it does. Okay, so this is having total bill and how much tip is paid to the restaurant, and what is the agenda, smoker, date, the time, and size. Okay, so how you can calculate the covariance? Basically, we have df dot covariance. That formula is there. So it is going to calculate correlation between all the numerical values. So let's say you have numerical value tip, you have total bill. So total bill versus tip, total bill versus size. Similarly, tip versus total bill, tip versus size. Okay, so all the correlation it will calculate between all the numerical value, between all the combination. So let's see what is your covariance looks like. It will be a kind of matrix or another data frame where all the numerical values will be only presented. Okay, so by looking at this, it may not look great, or you may have to really understand the value. So to represent this kind of data, right, you can have one visual effect by having heat map, heat map, and just put the covariance here. Okay, it is automatically going to plot those values with the help of different color. Okay, PLT dot figure, say fixed size. I just give it a 10 by 6. PLT dot show. Okay, so this is your heat map for this. Now, if I put annotation true, it is going to put all the values. So these values are nothing but representing the covariance. Okay, so when you talk about this, right, all are like positive correlation, means total bill is going high, your total bill difference. So this is what 1-to-1 I told, right? So when you take variance formula x minus mu multiply by x minus mu, this is nothing but this one, total bill versus total bill. This is your x and this is your x versus y. But now what is x versus y? So when your total bill is increasing, what is the impact on tip? Whether it is going high or low. What is the total bill? When let's say size is increasing, what is the impact on total bill? We know that if size is increasing, definitely total bill will also go high. So let's see whether it is really shown in the graph or not. And really variance is showing whether positive correlated or not. Okay. So what we can do now, let's do the scatter plot. So we know when total bill is increasing, tip is also increasing. So we should see graph like this. So let me use here. By with the help of theory, right? We know that if total bill is going high, bill will also tip will also go high. Tip. So let's say this is your scatter plot. Some values are represented here. Okay, and this is your total bill. Okay, so let's prove that with the help of the graph. I'll just use SMS dot scatter plot. I'm going to use x equal to df dot total bill and y equal to df dot tip. Let's see how it looks like. You see here. So this graph clearly tells, if you plot a regression line, right, it is clearly shown here when your total bill is increasing, your y is also increasing. You see here, it's very much clearly shown here. When you plot a regression line, right, which we'll see in the next learning, how to plot regression line. But I'm just telling you, if you plot a regression line, your total bill, as total bill is increasing, your y is also increasing. Okay, that is the correlation. So this is nothing but positive correlation, is what I was talking. And that is what is shown here. Total bill versus tip. Okay. Similarly, you can take any other variable also. Exactly same kind of impression will be shown here in the graph. Okay. Here all are positive correlations. So at least you'll see graph x is going high, so y will also go high. Okay. Let's take another data set where maybe x is going high, but y is decreasing. All right. So what we can take, let me see what else we have here. There is another data set in this that is related to MPG, right? Automotive data. Okay. So let's see MPG, what it represents. Covariance equal to Q dot covariance. Okay. So yeah, I see some negative value. These are negative correlation. Okay. So MPG versus displacement. So as MPG is going high, displacement is going down. Let's prove it. So first we'll plot all the things with the help of heat map so that you can clearly visualize. And based on that, you can pick whatever variable you want to pick. Okay. So you see here, so as displacement is going high, your MPG is going low. Okay, so this is one variable which is negative correlated. Okay, and 60 wherever you see positive elements there, these are positive correlated. MPG is going high, MPG cylinder is going down. So this will take, this is negative correlated. And as your MPG is going high, your acceleration is also going high. Okay, definitely. So it's quite obvious, right? And here we can take, let's say, cylinder versus MPG. As your cylinder number of cylinders are going high, your MPG is going down. Okay, so let's do some plotting and understand the correlation. What I'll do here, df dot, let's first plot MPG. If MPG is going high, miles per gallon, what is the impact on cylinder? As per this theory, or as per this heat map or covariance formula, it is going down, right? So let's see whether it is really going down or not. So it looks like there's no correlation. Why? Because value seems to be too less. Let's pick up some other value. Horsepower versus cylinder. What I'll do now, let's take horsepower. Or number of cylinders growing. What is the impact on horsepower? Will it be high? Should be high, right? Okay, so this graph is clearly telling as x is going high, you see horsepower is also going high, right? Let me take some other value. So I'll take 73 and acceleration versus cylinder also I can take. Let it be cylinders. Acceleration. Okay. Those are very much close to that value. That's why you see all the dots, right? And let me take some other value. What else I can take? MPG is going high, acceleration is going down. MPG versus acceleration. Let's try that also. Okay. So here also MPG is going high, your acceleration is going high. That is quite obvious. What else? I wanted to show some negative correlation. So let's see. Let's I can take model year versus cylinder. Let's try that. As model year is going high, your cylinder is going down. Okay. It doesn't look good. Acceleration versus let me take some other data. You have some more data. Diamonds. Okay, let me plot another covariance here. Covariance equal to df dot covariance. Okay, here also we see a lot of negative values, right? So definitely we'll find something. Heat map, where is that heat map? I want to show more points so that it can be clearly seen. Okay. Let's take if x is going, x is basically those are cuts x, y, z. Okay, for diamond. So let's see what are the correlation here. So let's say your price is going high, your depth is increasing or decreasing. Okay, so let's plot that. SNS dot scatter plot if x equal to df dot x and y equal to df dot depth. See if it shows something. Here also it is kind of, we are not able to get much what to say correlation here or covariance. I'll take some other value. So wherever you see zero, right, it will clearly tell it is not having any relation, right? Let's say depth versus y. If you take let's say y versus depth, if you take, right, you will not see any relation. As y is increasing, your x is also like very much same value, right? It is staying constant. Okay, what else I can take? Depth versus table. Let's see that. Not much correlated. Else I can take. So color bar, you understand, right? If lighter the color, like highly correlated, right? Like more correlation will be there. And here if you see zero means there is no correlation. And 0.6, let's see where is 0.6. So as price is going high, carat, more carat than more price, definitely it will be there. What else I can take? Okay, let me take, I had one example, some relation, MPG weight, MPG versus weight I can see. Okay, so let me show that. MPG versus weight, which clearly tells, yeah, MPG versus weight. Where is MPG and versus weight? Yeah, this is clearly MPG is increasing, but weight is like too much decreasing. Okay, so let me just show that. Yeah, this is also I was telling, right? So as your x is increasing, but y is decreasing. You see here, if you plot a regression line here, it is clearly shown that your as your x is going high, your y is decreasing. That is this one. This is clearly shown. So this is basically a negative correlation or negative covariance. So MPG versus weight only. Okay, when MPG is going high, like miles per gallon is going high, your weight is decreasing. Okay, definitely if it is high weight, it cannot move fast, right? It cannot give more what to say mileage. Less weight, more mileage. That's what it clearly tells. Okay, guys, so that's what I wanted to show in this covariance video. And we'll see, as I mentioned, the problem, right? If you change the unit of measurement, right, it is not going to show like a variance, whatever you are going to get before changing the unit and after changing the unit is not going to be same. Though we assume that it is going to be same, right? It is not like that. Okay, so by changing the measurement unit, your variance is going to be changed. Okay, so that kind of problem is going to be on the Pearson correlation, which we'll see in the next video. Okay, guys, so that's all about covariance. I hope you understood. If you did not, then please leave out the comment in comment box. I'll definitely help in the next video. Okay, and stay tuned for the next video. And those who have not subscribed my channel, please do subscribe. Thank you so much. Bye bye.